This is an example of a problem that's asking us to calculate the percent yield. And I've written down some of the information that I was given and that I'll need to know to solve this problem. But before I get into that part, I'd like to look at what is the equation for percent yield is. So percent yield is equal to the actual yield, which is the amount of a product that you get from a chemical reaction that you did in lab. So actual meaning that you actually did it in lab, you performed the reaction, you isolated the products and measured the amount of product that you got. So the actual yield is from lab. Now, for our problem, since we're not working in lab, this number is given to you. The only time this number wouldn't be given to you is if they're asking you to find it. And in that situation, they would be giving you the percent yield, not asking you to find the percent yield. So we take the actual yield divided by the theoretical yield, and then we multiply that by 100. And the theoretical yield is the amount that we calculate from the balanced chemical equation. So in Chapter 9, when we're calculating how much product should be obtained in different situations, we're calculating the theoretical yield. We're just doing everything on paper. So the kind of mistakes that you make in lab, perhaps transferring something or not having ideal conditions, don't occur in a theoretical yield because we're just assuming that everything is going to go as it's supposed to. So the actual yield is what you actually get in lab, and the theoretical yield is from the balanced chemical equation, using that in a calculation. So going back and looking at what I have here, in the problem that I was reading to make this video, I was given, let me get a little, there we go. I was given the amount of the CS2 right there in light green. I wrote it in red, and the amount of chlorine gas. And I was also given the amount of the product CCl4 that was obtained in the reaction. This number here is the actual yield. So the 64.7 goes in the top here. So now what I have to do to solve this problem is calculate the theoretical yield from the balanced chemical equation. And so this is a limiting reactant problem, and how I know it is I was given the amounts of both reactants. So I am going to use these two reactants to figure out how many grams of carbon tetrachloride I should produce. Now, before I started the video, I did calculate the molar masses of the two reactants, but I should have also calculated carbon tetrachloride. Let me do that right now. Times plus, I'm calculating carbon tetrachloride. Okay, so calculating carbon tetrachloride, its molar mass, I'll write it down here, is 153.81. Okay, so in blue are the molar masses that I calculated from the balanced, from the formulas. All right, so now we're ready to get into the problem. So I'm going to set it up first. I'm going to do the CS2. So I have 102 grams of CS2. Whoops. And I need to convert that to moles by dividing by the molar mass, which I calculated under CS2. I wrote it's 76.15 grams. I did not double check my molar masses, so if I made a mistake, then that will make the answer incorrect. But all right, so I converted it into moles of CS2, and then I'm going to multiply by the ratio. So this is what I was given, just so you see the steps. And hopefully by this point in the homework, you're starting to see its repetitive nature. So this is what I'm given, that I'm dividing by the molar mass to change it into moles. And now I'm going to multiply by the ratio from the balanced chemical equation. So let's see, there is a 1 in front of CS2 and a 1 in front of CCl4. Okay, so it's a 1 mole CCl4 to 1 mole CS2. And then finally, what I'm going to do is I am going to multiply by the molar mass of CCl4 to change it into grams. And I want to change it into grams because if you look at the actual yield they gave me, it was in grams. And so if I have grams in the actual yield, in order for the units to cancel, I'll have to have grams in the theoretical yield. All right, so let me do this. So it's 102 divided by 76.15. Then it's times 1 divided by 1 in the ratio, so that's not really changing it. And then times 153.81. But I put 156. Let me change it. 153.81. And I get to 3 significant figures, 206 grams. And this is carbon tetrachloride. Now that if I only had one reactant, that would be the answer. But since I have both reactants for a limiting reactant problem, now I have to do a second comparison problem. So I'm going to start with Cl2. So again, I have 102, which was given in the problem. You can look above. It's what I wrote in red. I'm going to divide by the molar mass of Cl2, which is 70.90. Oops. That cancels out the grams of Cl2 and gives me moles of Cl2. Then I'm going to multiply by the ratio. And if I notice in front of Cl2, if you look up at the top, there's a 3 in front of Cl2. So it's going to be 3 moles of Cl2. And there's still only a 1 in front of the CCl4. So that gives me moles of CCl4. And then I'm going to multiply that by the molar mass of carbon tetrachloride. That cancels out, and now I end up with grams of carbon tetrachloride to compare. So let me plug that into my calculator. And I get 73.4. Oh, no, 73.8. I'm sorry. Now, so if you remember in limiting reactant problems, the answer is the smallest value. So this 73.8 CCl4 is going to be the theoretical yield. This is the answer here. So that means that this is the limiting reactant. And so in all transparency, this number up here doesn't mean anything. We just needed it to compare which one would give the most or the least is what we wanted. So now 73.8, so we're nearly at our answer. I'm going to take that 73.8 from the previous page and plug it in here. And then I have 64.7 divided by 73.8 times 100. And I get to three significant figures, 87.7% yield. So you can see percent yield really just added one step, and that is plugging into this percent yield equation. Otherwise, we calculated the theoretical yield in a similar way to previous problems, and the actual yield was given to us in the problem.